cloud because the cloud is based on immutable infrastructure. And I'm going to talk a little bit into what is mutable and immutable. Uh, but the great thing about it is that now that we can build this infrastructure, we can also build detections, and we can do detections as code. And when we mix these two things together, we can test the detections, see if they work or not. Isn't that we're past the time where we had to basically sometimes ship detections that sometimes it was impossible to get data. It's not that we have taken away that. There's still issues with it. But now, with the availability of this tool, pretty much anybody, you need a laptop that if you don't want to pay AWS, we're mostly based on AWS. With a laptop with 8 GB or 16 GB of RAM, you will be able to run this. So to finalize the Splunk attack range definition, we do have this integrated into what we call a continuous integration, continuous delivery, which basically we test our detections that are created on the go, detections that are in the past. I recently wrote a blog about creating a zero logon detection based on the attack range, and I can give you that link later, and I can show it to you. That blog actually ended up being shown in mentioned in the Department of Homeland Security Emergency Directive for zero logon. So this is something that you can use. You don't have to pay anything. You had to pay something to AWS if you use it, but if you do the local one, you don't have to pay anything. Bandwidth, basically. So here's the attack range, and I think I show you that. It's right here, and this is where you clone it. So let's talk a little bit about the architecture of the attack range. The attack range, basically, there are several architectures, right? This one is sort of like the general one that we use and the main branch of it, where we build it and configure it using Ansible. And then we have a setup in AWS that has Active Directory. It has a Windows server. There's some work on OS query and likely Debian flavor Linux. You can also get in a Splunk server, you get that always by default. And you get a MITRE Caldera framework install with the agents already running into the machines that you selected. I'm going to show you that in a few minutes. And you can actually expand it, and you can select Splunk Phantom if you want to play with Phantom. You're going to need a account in the Phantom community, but you can still use it. And then, of course, we had to add it because it's an essential tool that most of the researchers use, which is Kali Linux. So in Kali Linux, usually it's not difficult to download code and replicate an exploit. And that was the goal. The goal of us doing this was, I've been a researcher for over a decade now, and I know how hard it is to create data. And I actually have a lot of gear, if you want to call it, and I have a lot of storage where I have tons of VMs from very old operating systems, newer operating systems, complete domain controller, Active Directory, print servers, you name it, because there was simply no other way to do this. The only way, thanks to virtualization, and that sort of says a little bit how old I am. We went from, I remember still walking into a rack server there and asking, can we fit my research server there? And they're telling me, no, we can't do that. So we went from there to being able to use or create virtual machines by hypervisors, and then as VMware Workstation, a virtual box, which we still use, by the way, in our local range. And now we can actually deploy all this by basically configuring a file, and then this basically will deploy, will be connected. There will be an internal network. They will be able to ping each other. That setting is already covered. And the credentials will be configured. The atomic red team will be configured, and you can execute the attack straight from the command line. You had to spend hours creating this. If you want to do the local one, it will take a little bit. I had to tell you that. But it's something that you can keep or you can reuse. Now, one of the reasons why we decided to create this and use this in the cloud, there's certainly a trend in Silicon Valley to use, take advantage of what is called ephemeral, immutable infrastructure. So ephemeral means we use this, we replicate the attack, I destroy it. And actually, we're going to talk about that in some of the commands. And it's called immutable because basically this infrastructure is usually patched and set by the cloud provider. The mutable infrastructure is sort of old school. When we were inside the perimeter, we have our servers, we had to patch them, we had to apply all kinds of updates and security patches. When we go to the cloud, we're dealing with basically platform as a service. This for the most part is immutable and should be used in an ephemeral way, meaning when you're using this in the cloud, you never leave this on. We don't do it. We basically, what kind of attack am I trying to replicate? Okay, this is this type of attack. I deploy my range and then I destroy it. That's it. I don't keep this. Why? Because it costs money, among certain things. And second, because sometimes because of the setup, the machines may get popped, for example, and that has happened. And then that may, you may get yelled at by the AWS administrators, but the intention of this is not to keep it running. This is, again, is ephemeral. You use it, you test it, and then once you're done, you destroy it. You need it again, you build it again. It's right there. It won't go anywhere. So let's get a little bit into the specifics of what we have in every machine, right? Because it is important for you to understand when we're gonna go into the part of the detection, what is it, what type of data is that we're looking at. So again, we build this via Terraform, going to AWS, and Ansible basically does a lot of the configuration of the machines. In the Windows machines, we have Sysmon. We actually use a very verbose Sysmon policy, so you're gonna get tons of logs. We have OS Query. We have Caldera. We have Atomic Red Team. We have Splunk Streams, which is a packet, sort of a packet DPI, deep packet inspection. There's also a Seek module. We're not going to see it today, but Seek, for those who don't know, is what it used to be called Bro IDS. So you can also use Seek and take a look at the detections and take a look at the packets that are coming, that are generated from the attack range. And then, of course, you have the Splunk Universal Forwarder, which is what sends all the stuff from the Windows machine to the Splunk server, which is mainly where all the data ends up at. So let's continue. So basically, what do you do before you run this? You had to install the OS dependencies. You had to configure Terraform, which is usually is Terraform space init. You had to the configuration in the attack range.conf. That's very important. and then you simply type Python attack range action, although we changed this and now it's basically A-A build. And then here, basically once we're done, we do A simulate the target, which will be the machine that we'll be looking at, and then we run a detection. And then we can run a Caldera operation if you want. So for those of you who are following, here are the two main links that you need to pay attention. One of them is the Ubuntu setup. Let's see if we can take a look at this pretty quick. And then here's a complete guide. We try to make this as easy as we can, guys. If you have any issues, if there are things that we need to change, please let us know. And we'll be glad to do our best to fix it. You can always create a PR too. You can create a pull request. This is an open source project. And as you can see, this actually was with help from people that were testing it. Here's the steps that you had to use and perform in order to build it. And then if we go back, there's also the Mac OS X installation, which is of course what we pretty much build it. But why am I showing you this? For many reasons. Of course, we want you to do a flawless and easy installation, but I know that there are times where people issue Windows machines, or they only have Windows machines, and one of the way around that using the range is if you're using AWS, is basically doing it through a Ubuntu machine. So when you go on the Ubuntu machine, virtual machine, you can perform all these steps and do it from there, because we don't support Windows as a hosting platform. So you're gonna have to do it either from a Windows, so through an Ubuntu VM, or you can do it from a Mac OS. We have people that have been very successful doing this. And we unfortunately, we do not support sort of the hypervisor inception, meaning you create a Ubuntu machine and then you run Vagrant and VirtualBox in it, so you have a hypervisor inside a hypervisor. We don't support that. We know people that have been successful at that. Basically, they have like this monster Windows laptops, but it's not supported. So those are the options that you have right now. Or basically, if you have a cheap VPS or VPC and you're doing the cloud one, you basically SSH into it. Make sure you choose Debian or Ubuntu, and most likely all of this will work. So let's continue. Okay, so now this is something that for us has presented a challenge. And it has presented a challenge because, in all honesty, guys, we didn't want to do a local one. We started with a local one. I remember almost a year or something ago when I went back to Splunk. And then we realized that if I'm going to have a Windows server, a Windows client, another Windows server, a Kali machine, a Phantom, and Splunk, it was going to eat all the memory on my local machine. And in fact, at one point, before you build your local one, if that is what you want to do, and actually, let's go ahead and show you that as well. Attack range. There's actually a link in the main one. There's an attack range local, right, which is right here. And you would not be using anything in the cloud. You don't have to worry about setting up Terraform. You don't have to worry about downloading the SDK, the AWS CLI. And again, there is right here all the instructions. I'll get to this in a minute. I don't want people to freak out and say, I don't want to do AWS, which is something that has happened. Uh, and by popular demand, we basically had to branch out. Why did we have to branch out? Because here's where things can get confusing. We basically realized that we had to maintain two branches, one for the local and one for the cloud. And then we made it even more complicated and created a cloud only, which I will be showing you today. And we're actually gonna use a brand new attack framework that I'm not sure if some of you guys have heard. It's called Leonidas. So hopefully, if the demo gods are good to me, I'll show it to you. But let's go back at why we had to branch. We had to branch basically because we found out that any standard researcher or defender, you usually will have a device that has either 8 to 16 gigabytes of RAM. Now that it's becoming cheaper, maybe some of you are getting 32 gigabytes of RAM. Good for you. I don't have that. And I realized at one point that when I had 4 to 5 virtual machines, basically my computer will halt. So then we realized, it's probably not a good idea. And plus, the idea was also to destroy it, right? You destroy it and build it back up. When you build these machines locally, they take space. It takes time because you're gonna have to download all those ISOs. Don't worry about it. The script does it for you. The script basically, all you had to do is you had to install Vagrant. You had to install Vagrant and VirtualBox. Make sure you have the latest versions of it. Clone the repo. Make sure you have the actual dependencies, and basically build it with the action that I just showed you. Right. This used to be the alt command, by the way, but it will build it. And how, and we're gonna get into that in a minute. What is it that you tell it to build is all in the attack_range.conf. So that is the local one. And then we have the cloud one for endpoint, which is how we're calling it now, which does sort of a similar infrastructure. But remember, there are two differences here, and this just happened to me with Zero Logon. When we try to replicate Zero Logon at the cloud, the Windows machine obviously was already patched. When we try to replicate on local, it was not. And it was not because that is an ISO that we selected. So that's something that you may want to consider different wise, because again, we go back to the concept of what's mutable and immutable. And of course, this cloud providers, they already have patched it by the time we started to test it. So this is pretty much the architecture. And let's move on. So I think I spoke already about this. Here's a little more detail of some of the things that we have. We have in Splunk, for example, we have the ESEU. The ESEU is the content updates, and where we actually push as a team our detections. All of this is free. You can download this, you can build it, and it will be right there for you. There is an actual nice dashboard, which I will show you, that actually will display what simulations you have executed, and then we can go back and look at the data. And here are all the machines that you can potentially have, right? For a domain controller, you can choose, for example, if you don't want a domain controller, you can have a server, and the server will act like it was a client, for example. There's a Windows Workstation setting, which is, I believe at this point, is only for local. We couldn't do that in AWS. a Kali machine, a Splunk server, and a Phantom server if you want to play with it, right? So if any of you is taking classes or want to get introduced to Azure sort of technology, you can actually download this right now, and it won't cost you other than your work and broadband to set it up. So, like I said before, most of the stuff is on attack_range.conf, which is where we're going to select what to install. So here's a little bit of a cost estimation for AWS environment if you're planning to have it. Again, my personal experience is that this is ephemeral. You should destroy it once you're done. If you can pause it, by the way, you can pause these machines and then bring it back, so they don't have to be running or showing services on the internet if you don't want to. Obviously, if you're using AWS, the use of security groups is highly recommended. And you can actually use the estimated costs. It doesn't cost that much, to be honest, but some people don't want to pay much and or need to allocate budget, so you can actually take a look at it. All right, so let's start getting more into what is it that we're going to get here. In this case, what we're going to be doing is going to be registered mainly in three indexes, sorry. So we have mainly 5 source types, but we do have 3 main indexes. So in the index equal win, and you will see this when I'm able to execute the simulation and look at the logs, we're going to see the Windows event logs. And in Windows event logs, you're going to get the event IDs, mostly for security. And we actually enable the audit within the machine, so that way it's very verbose, and you're gonna have quite a bit of events. We also have a system policy, which is very verbose as well. We sometimes, remember guys, when we're using this tool and we're replicating a brand new exploit or something that we're not I guess familiar with, we don't know what we're looking at. So the most we get, the better for you to come up with a detection or to understand what is it that this new exploit, this new vulnerability is all about. So you're also going to have PowerShell logs. You're also going to have network logs with a stream, which is set up as well. And you're going to have attack simulation logs from Red Team. I believe you might still get Caldera, some of it. I will go over later on. So now you know that. So that way, when you log in your Splunk, you know what to look for. We do have now a deployment that actually has a Kubernetes cluster for those who are interested in looking at Kubernetes. We're actually deploying a WordPress, and also there's a serverless deployment, which I haven't used yet, but you can also use it, and it consists of a Lambda, REST API, of course uses S3 and Dynamo DB. I'm not really familiar with this, and I plan to explore it in the future. We haven't really gotten much of a request to use this, but it's right there if you want to use it. Okay, and this we're going to see today. This is the new attack range local. An attack range local, by popular demand, because some people didn't want to do anything with the cloud. You're going to be able to have a Windows server, domain controller, that Windows server, and you can have, we're still working on the Linux endpoint. I don't think it's released yet, but you can have your Kali machine. and you're gonna have your Splunk server and your Caldera server, as well as Phantom if you decide to deploy it. Did I come down? Okay. Here is the the configuring steps. If you're doing Terraform, you can see most of this on the page. You're gonna need Terraform if you're doing AWS. It is important that you download the AWS CLI, and it is important that you set up the correct key pairs. Without the key pairs, you will not be able to connect to your machines, and you will get errors. And that's usually something that I need to emphasize, because usually when we do these workshops and people start building up these ranges, we get a lot of complaints that you get, I think it's a 400 error. And the 400 error usually indicates that the keys don't match. And because the keys don't match, you're not gonna be able to connect to your machines. So let's see what we got here. I believe we talked about this. Some of the other stuff that we can look in the Splunk server, we have the protections as I suggested. At ESCU, we also have the machine learning toolkit pre-installed in it. The UI is at port 8000. And you can also SSH into it. It's an Ubuntu machine. And I already told you about the three main win and attack, which is the main indexes that you're gonna look at. In some cases, we actually have a Splunk ES in it. You can use it for a while. And same thing with Phantom. When we look at our machines, these are things that you're gonna keep. Like we're talking about the local one, right? These are machines that you're gonna keep. These are machines that you can actually RDP into them. You can modify these things. You can exploit them. You can reboot them. You can do everything you want with it. On the atomic red team, which is it's a big part of what we do attack simulation, right? And the attack simulations are based on what they call atomics, and the atomics are based on TTPs that are publicly available at attack.mitre.org. So if you go here, probably a lot of you guys are already familiar with this. You will see a lot of, basically this is a distribution of TTPs, and a lot of this, notice that there is a technique, right? And we're gonna be performing these techniques and some of the sub-techniques in a few moments. So it is important for you to understand the method theory of this. Where is this coming? This is coming from basically the replication and the simulation of these tools coming from the attack framework. Although, because you have now this infrastructure, you can choose to do whatever you want. I basically replicated zero logon with the same setup that you're about to see, and that's the purpose of it. I'm not gonna talk about Packer. This is sort of deprecated, and it's for certain specific people who wants to use it. One more time, I would like to say this, depending if you're using the AWS, you have to enter the right key name. If you don't enter the right key name, your machines will not be able to connect. You will not be able to log in into your machines. And to make it even clearer, here's a picture. So you had to go on AWS, you had to create your keys, and you had to name your keys. And when you go into conf, your keys had to match. Your keys, had to match the name. The keys don't match the name, you won't be able, you will get errors. Following that, you had to configure your instances. So you do that by going into, let me see if I got stuff here. Are you guys still able to see my screen?
Yes, we can.
Okay, perfect. So just to show you right here, what we're looking at right here, just for a second, because I wanted to show this, is the attack range cloud. So in the attack range cloud, if you go here and you go nano, I hate them, sorry, cloud attack underscore range.conf. This is what I was trying to show you. In this case, we're looking at the password, for example. We're looking at where the keys are. You had to put the keys. You can see specifically where the apps are being downloaded from. You can change this if you want. You can see where the binaries, the version of the binaries are downloaded from. You can change this if you want. You are likely to may want to set your own for certain things. We have found companies, actually. Let me get out of here and do another tab. And then let's see what I got. I got all kinds of ranges here, guys, but let's see if we can do attack range. Let's do attack range. Right. So if I go here, here's the whitelist. This is something that we're actually on the newest versions, they're gonna force you to enter your IP address. And the reason that we're doing this is because we got tired of being yelled by the AWS people. So basically, we're gonna force you to basically set up, the script will basically set up a security group that will only allow your IP address. You can go to what is my IP and do your IP CIDR, right? You can put in your CIDR. So that way you don't have people poking around. Now, if you want to set up a honeypot, that's a different story. You can modify this and you should be fine. So remember to input your region, your passwords. I always forget my passwords, and because this is ephemeral, usually, if somebody's running some sort of a brute force, it would take them a while to find it, and it will be destroyed by the time I'm done. Here's the TAs that we pull. So you can see specifically every single thing we're doing. The data sets, actually, you can actually import the data sets from Boss of the SOC if you want. Some of you may be familiar with Boss of the SOC. I had the privilege of being part of the Boss of the SOC team. I was basically in the floor, and I never seen over 1,000 people with computers playing a defense that capture the flag. Is very impressive, and the guys do an amazing job putting all these data sets together. So you can actually obtain these data sets and import them into your attack range. The community username, like I told you, for Phantom, you're gonna need it. And then here, the Windows settings, the username, the password. Here's where we're downloading the Sysmon and the universal forwarder. You would also see the Sysmon template. I told you we use this template, which is incredibly verbose. It's pretty good. It's the best in the industry so far. And then we have other things like the MLTK, if you want to install it, DSP, which is a new product that we're Splunk is developing. So this can get, guys, this can get very, 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 very complicated if you want to. You can make it as easy or complicated as you want. There's a lot of code here, a lot of code. And here's simulation techniques, which again, I'm gonna show you in just a few minutes. Um, and then the environment, right? So do you want a phantom server? If the answer is yes, you type 1. Do you want a domain controller? If the answer is yes, you type 1. And this means the script is going to turn your Windows server into a domain controller, which is it's a big difference. It's not just a server. It will actually do all the steps required to turn it into a domain controller. Then you can have another server and you can select if you want it to join the actual domain controller. And then, of course, if you want to have a Kali machine, you can select it as well. Then we have the private IP addresses of your environment. So everything is here. Everything is here. You can change it. You can modify it as you want. Notice that we even give you the name of the operating system that we're using. Do you want the client to join the domain? Yes. So I wanted to go and basically show you, because this is usually where things can get complicated if you're using AWS and you're confused. So you can take a look at the things that you may have to input. Remember, it's not that in the cloud one, it's not that easy. You basically have to clone it. You have to install an environment for it, install the dependencies. It's in Python 3, and then you got to go into conf, configure it, and then build it. And it takes around 15 to 20 minutes if we're doing the endpoint one in the cloud. That's what it's going to take. If you're doing the local one, which I already built, and I have it here to show you today because it takes quite a bit depending on your broadband. If you're downloading all these ISOs and they're being set up by VirtualBox, and of course, there's a bunch of scripts that require the machines to reboot and then be reconfigured. It's going to take time. I would say that to have like a full local environment, it's going to take you plus an hour. I would say it's more than an hour. It's going to take you more than an hour. So I believe this covers the configuration, and then I can go back to show you, and we can move on. Let's talk about adversarial simulation for a second. Now that I have shown you the infrastructure that you can do it either locally, you can do it either in the cloud for, you can do it in the cloud for endpoint, and you can do it in the cloud for cloud-based only attacks, which is the latest thing that we're doing. And I will show you that. Hopefully I will be able to show it. Let's talk about what is it behind all this. It goes just beyond the simply just setting a bunch of machines, connecting together, and replaying some code. So what we want to do in adversarial simulation is we want to test applications, network applications, or specifically host defense architecture resilience against an attacker. So there are many frameworks that do this, and I already touched in one that have a number of attack actions, items that are taken from known exploitation and post-exploitation actions. And these are usually called TTPs. Now the TTPs have been defined. Who has defined the TTPs? I would say that before we had attack, we had the private industry coming up with fancy names, you know, APT1, APTX, fancy there, whatever you want to call it. And then eventually all this has been sort of moving into a nomenclature. And this nomenclature, which is currently the one that is widely accepted, at least in the United States, by government and private sector, is MITRE, right? So we talk about MITRE. You must know MITRE. MITRE is basically the language that we all talk, like starting from this. So if you do reports, if you do forensics, if you do pen tests, if you do vulnerability assessments, I mean, you had to know what CVEs are. So CVEs, all this database and nomenclature comes basically from MITRE. And now MITRE uh, continues coming up with this type of systems of nomenclatures. And one of them, which is the one that we are referring specifically because of adversarial simulation, is MITRE ATT&CK. And within that MITRE ATT&CK, there are what we call the TTPs, which is techniques, tools, and procedures. Now, this is something that I want you to remember as we move on. And I will talk a little bit about some of my experience with enterprise companies using this tool. Um, and and one of the main things that I usually tell these companies before they deploy this, which is, by the way, something that we never expected. We it's kind of interesting that I brought you from the basics, from the mindset of a single researcher, defender, or a security engineer. Because sometimes I know we wear many hats, and there are many companies that don't want to hire anybody else. And you happen to be the one single person that does everything. This is wonderful for you. You're going to learn a lot. But there are other companies that have very large departments. I remember I was at one point I was an engineer. I was a systems engineer, and I was working for a company in Philadelphia who had 30 people just for McAfee antivirus. So it was around 3,000 people, IT department, and just for the antivirus there were 30 people. So we go from the streams of you are the one and single only security engineer to very widespread and super large. With several locations and all kinds of infrastructure, but the 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 main thing in all this is the golden image. So what is a golden image? A golden image is a let me put it this way, is the representation of your company's device that comes with a specific software and that comes with a specific configuration. So if you work for any company, usually depending on the level of maturity, eventually every time somebody joins in, they're assigned a laptop. You get a ThinkPad or you get a MacBook or whatever is in your area, Dell, and then you had to have Word, Excel, or whatever is it that is applicable to what you're going to do. And of course, there is an inventory of versions of this software, of licenses, of course, and the hardware that you're using, right? So a golden image is basically we make either an ISO, or in some cases, which is crazy, I never thought I was going to see that. Basically, a actual replication of a physical machine that represents what is given or what is provided to the employees or what is deployed on the network. So that is the golden image. Golden image is the representation of your company, the software and application posture. So for you to have a actual valuable result from these tools, you can use these tools. There are many other tools. There's a market around this, right? For you to have a consistent and something valuable, you need to test this against your golden image. If you do not do that, then basically what you're doing is an exercise in curiosity, because you don't know, right? Remember, we're talking about this TTPs, right? Tool techniques and procedures. This tools, techniques, and procedures are attributed to specific groups of adversaries, right? There are groups. Actually, let's actually select one here so you can see it. We can select the one random, right? So this is exploitation for credential access. Usually you have in the reference, of course, I selected the one that didn't have it, but if we actually go into some of these things, usually in the references, you would actually see what groups are associated with it. See this? So in this case, this is create account, local account. So if we looked at the basically the technique is creating a local account. It affects these platforms. It is related to a tactic stage associated with persistence. Persistence is the ability to stay at targeted as a targeted organization after I exploit. This is post exploitation. So this technique is associated with these groups. And these groups, like I told you before, some of this come from the industry, private industry, from the CrowdStrikes, the Silences, the FireEyes of the world. But it's important to understand, right, that the reason why you want to do adversarial simulation is because technically you want to do an exercise to see how your organization will do if you were attacked by specific adversary, or more specifically, if the techniques known to a specific name group or adversary were performed on your network. In order to determine that, you must use a golden image. And the golden image can be created locally, or the golden image can be created. You can have a golden AMI. There is actually an entire procedure how to create a golden AMI if you are a person that has an infrastructure that is based on the cloud. If you're going to run these tools, and remember, we went from use it as a researcher, use it as a defender for detections, or use it as adversarial simulation. So if we're going to use it as adversarial simulation, what we're providing you will give you guidance of how to set it up. However, I would say that you're going to have to do some work to likely customize. Like, for example, let's say we build a Windows machine. You may have to use the ISOs that you use at your company. You may have to modify the scripts, the building scripts, the Ansible scripts, or the background variables in order to bring in stuff that is in your network, in your company, and then perform the simulations. And then obviously you want to see, okay, what happened? So if we use technique X against my desktop golden image, how will we do? So here's one of the things that I've been seeing lately, which is enterprise, very large companies that are using this framework, and they're applying it inside the perimeter, and they are modifying the instances. In some cases, they're just deploying the agents of the framework. Remember, Caldera has an agent, and so does Atomic Red Team, and they are replicating these attacks and then doing purple team exercises where they're able to execute or replicate these attacks. Remember, I just show you, give you an idea, and then, oh, let's see what happens. Was this technique executed successfully? Why we didn't catch it, for example. Or I had a session with a customer that basically they wanted to see if their SOC will catch. Like if let's say you work in a specific industry and you're concerned about a specific adversary, let's say FinCEN, for example, or Fin7, or whatever name we can come up with that is related to your industry, and we're able to replicate most of the techniques that they do, how will we do? And that right there is a very practical application adversarial simulation. I would like to caution about if you're watching this and you're thinking about it, you can reach out to us and we can give you some guidance. But remember, I particularly as a pen tester that I still are, I love to see things that run a system and they're running on computers are probably gonna go and attack them. So these are frameworks that I'm not sure if the purpose of when they were developed was for you to leave them there all the time, right? So this is something that if it's going to occur, it's almost like a fire drill where you do it, you measure what happened, you raise the alert, you see how your teams respond. We do a lessons learned and what are the results of this, and then this is dismantled, and you go back to your benchmarks, and then the benchmarks are adjusted depending on the results. But leaving this live on inside the perimeter, I particularly would not suggest you to do that. And I would not suggest you to even leave if you have a local attack framework that has not been configured or hardened according to your InfoSec policy. We'll go back to the golden image to leave it on. Right? You never know what can happen, and you don't want to provide extra doors to will-be attackers. So the benefits of this, obviously, is, like I was saying, you will measure response capacity, you will measure risk level, you will basically measure very specifically your attack surface. Not all of it is too ambitious to say you will, but at least we'll go from, okay, we can do a tabletop exercise and talk how cool it will be if we responded, or we can have a pen testing team come, which is, that's also valuable, or we can replicate the exact techniques that a number of adversaries will use against us and see how we do. And like I was saying, things like detection telemetry, are we getting this? Like a local account was created, did we detect it? Did our IR team get alerts? Did our SOC pick it up? Were we able to isolate, for example? There are, I'm not sure how many of you probably familiar, but if you're using ZOR, like Phantom, for example, Phantom has playbooks that if a specific type of command is detected, or on a specific type of malicious code could be detected, the machine is immediately isolated from the network. It runs a playbook that basically is a bunch of commands. Imagine that you are at the machine and you're basically disabling it, taking it away, sends a message and said, this machine has been disabled, you gotta go and take care of it. These are things that can be tested with this. And that's definitely a very high value from the sense of a blue team, from the defense perspective. And since we were talking, adversarial simulation can provide a view beyond unsuccessful pen tests or red team exercises. Adversarial simulation it does not replace pen testers, or there are great pen testing teams out there, internal and commercial, and there are good vendors and procedures for red teaming, but adversarial simulation does not replace that. It's also a part of the tool set that you can use. And of course, this is another advantage. There are certain scenarios, there are certain adversarial simulation scenarios there might be safer to run than pen testing or testing techniques that are potentially disrupted or destructive. And I've seen that myself, where I, as a pen tester, usually I want to make sure that if I'm going to be scanning, for example, or there are like legacy devices, fragile printers, mainframes, things that have TCP IP stacks that are very old, and that if you send in an nmap scan, this thing is going to crash. And I'm sure some of you are listening saying this happened to me once. You can get in trouble. And there are places where this may not be safe, especially in many financial institutions that have lots of mainframes. So running this type of scenarios might be safer from the perspective of what is control and what is that we can measure. And of course, this is wonderful for blue teamers. And finally, uh, on the advantages and disadvantages, um, some caveats about adversarial simulation. Uh, it does not prevent 0 days, obviously. It only reflects an ability to react. And the ability to react, it will be based on a lot of the factors that we just talked about. This does not replace pen testing or bug bounty or red team. Uh, as you can see, a lot of these actions are post exploitation. Um, and you may have specific apps or specific scenarios that are not covered within these frameworks. Nor all the frameworks, by the way, are able to replicate all the atomics or all the, there are atomics that you can't replicate. There are TTPs that are, because of data or because of code, you're just simply not able to replicate it. So there's a universe, there's a sample universe of all these TTPs that we can test. But regardless, this helps. And of course, like I said before, and I want to re-emphasize, there's not much of a value if you do not test against a golden image. There's not much of a value. What you're doing here is basically an exercise in curiosity. You're not really gonna get valuable information to act. You're not gonna get information that it says, oh wow, look, we run APTX techniques and they all went through. So if somebody uses techniques against us, it will be a bad day, right? So these are things that the only way to measure them is by testing these frameworks against the most accurate representation of what your infosec policy is, of your applications, your whitelisting, et cetera, et cetera. Now, there is, right, certain people that says that there's a questionable accuracy because a lot of times you had to disable EDR and the antivirus. So many people say, okay, well, yeah, we had to disable this in order to run it. So how accurate this is in reality? I still think this provides a value. I still think that there is definitely something to get from adversarial simulation, but obviously you have to have all these caveats. The hype in the infosec industry always promises you get one product and you get it all, and that's not true. And like I said before, actually, I just said this. These tools, uh, this should be fixed here. These tools partially depict sophisticated adversary actions. You can't possibly think that because you replicated a number of TTPs from a specific um, adversary that is related to your industry that you're protected. I mean, it's foolish to believe that. You have a sample of it. You have maybe a good measure of what may happen, but you can't say, oh, if APTX comes here, they can't do anything because we already tested this and we already covered it. Don't fall for that. Obviously, I'm sure you guys know better. Uh, um, Once a tool or a technique has been published, and I know this firsthand because I did this for years in my years of BLX, where we will literally get attacks in DDoS code that nobody else had, but we had it because we had our own ASN. Once you publish the signatures, and there's a community of signatures for Sonord, for now that there's a good drive for playbooks, for Jupyter playbooks, for thread hunting, for packet catcher. Most of this stuff is burned. So the adversary is likely not to repeat or improve their techniques based on what they know is out there. So once that stuff is out, it's usually burned. So let's get on to now, what is it that we are including in the engines before we start running simulations here. And hopefully you're still with me. Hopefully you had time to download this. So by the time I get to the actual demo, maybe you can do it with me. So we decided to include MITRE Caldera because it's developed by MITRE. So Caldera is a cybersecurity framework to run what they call autonomous breach and simulation exercises. And it can be used as a manual red team engagements or automated incident response. Caldera is way more than just simply replicating TTPs. We put it there. My experience with Caldera is that you have to get acquainted to it like any tool. Some tools are easier to get a hold on and execute, and some others take a little time. You will see, I'll show you a little bit today. I'll definitely suggest you have nothing to lose. Basically, all you have to do is clone it and download and practice about it, because you might actually get into it. You might have or find a very good use for it in your organization. And of course, we have ART, Atomic Red Team, and Atomic Red Team has been a pioneer basically on the replication of these TTPs. And we definitely continue to support it. We're happy we chose to use it. It's a great company, and they do great things. But specifically, the fact that they were able to create this repository and give it away to the community is pretty awesome. Again, this is something that I need to reemphasize. Most of this comes from the MITRE attack framework. So we come from the met theory. What is it that, how are we going to understand these actions? These actions are not just code that runs. These actions come because they have been selected after either vendors or government or researchers themselves had categorized and had agreed upon in a single, shareable, and accepted language. And that is the language of the technique numbers, or the common vulnerabilities and exposures of CVEs, or there's also web techniques here as well that are included. So let's get to see if we can run an attack here. So right now, here the supported actions for the attack range. Obviously, we got to build it. We got to perform an attack simulation. We can search with obviously Splunk. We can destroy it, stop it, and resume. So let's see if I can see what's next. Here's some of the commands. I'm going to leave that there, and then I'm going to go. Hopefully it won't kick me out. It did. So let me look at the local one that I have here. So let's go into attack range local. So here I had to obviously be the environment so I can execute my commands. You will see this, and just in case, why do you do that, Rod? Okay, when you actually, before you install it, you had to install obviously the dependencies. So my suggestion for you is to create a Python 3 environment do a pip3, that's our requirements, and that's the easiest way to do it. So let's see, if I were to do Python attack range underscore local, and let's type help. So those are the commands that I can do. I had stopped the local, so let me actually do A as an action and then type resume. See what happens. Hopefully the demo gods are with me. And if the demo gods are with me, you start seeing popping the virtual box. See that? The command prints out, and yeah, I see some blinking virtual box. So here's my attack range Splunk server. I'm sure soon I will get the Windows one and the Kali. So I have a MacBook with 16 gigs of RAM and an SSD, and you know, this is also to give you an idea of how long it would take if you decide to do. You gotta make a decision if you want to do it locally or if you want to do it in the cloud. So as you can see, we have my domain controller there. Here's the Ubuntu with the Splunk and Caldera running. And we should be able to see the Kali soon. Let's see if it pops up. So as you can see, it takes some time. You can actually see everything that's going on in the background. And in just a few seconds, I would do a command that you need to know in order to, in case you forgot, right? You forgot, for example, whether your IP address were, or like me, you forgot what the passwords are. So we should be able to see the actual domain controller in just a second. And okay, there's my Windows machine. And looks like I had an issue, but if I do this, for example, I should be able to see my IP addresses. All right, please tell me you have them. So I should be able to see, there it is. So as you can see, we had an issue with the Kali machine, I believe, but we now know where my IP addresses are. As you can see, it couldn't bring it on. Now I could probably cheat here and go into VirtualBox and probably bring it up, but we're not gonna use it for now. So let's let's try to replicate an attack. So now that I have my machines on, actually let's go ahead. So you see that that this actually works. And as you can see, this is my local IP address. I'm gonna put it right there. And there is my Splunk. So here, I believe, in case this happens to me all the time, I just gotta go back here. Then I go, no, attack range. And then I'll go here, and it's, oh look, this is my password. It wasn't, that wasn't. So I copy it. This happens to me all the time, by the way. So I just go here, and here, with my password, and there I am. So if I go into search, remember I told you there's an index equal name, correct? Right. There's some events there, right? You can see, let's see, let's take a look at it. I like to do this all the time. Is this too big for you guys, or is this looking good?
Yeah, the size seems good from my end.
Excellent. So here's the main, and now let's go to the win. And then we're going to win. We got, as you can see, the XML And then here, we have the processes. This is obviously coming from Sysmon. We have destination IP addresses. We have hosts, actions. See if we can get event code. Very important when you are looking for things to happen after you execute certain codes. See what else? Process ID, process execution, protocols, source addresses. So there's plenty of stuff here, and there's 229 more fields, right? Okay, it gets even better. Check me out. I'm gonna go here, and I'm gonna go to the attack range reporting. Look what happens. I had executed some techniques here before, and oh, looks like I have an issue here, but I wonder what happened because I tested this. But here, when this works, you will see the amount of techniques that you executed. Actually, we did today. So let's try actually to execute. So let's go back and do help. Okay, so I'm going to do, I want a action, simulate, and then I want a simulation technique. I want to do the 10, the 0, the 0, 3. I believe I can do 0, 1. And the target is going to be the domain controller, obviously, because that's the machine. That's the only machine we have right now. So if I go here, I go execute, and then now we're calling atomic rec team, and atomic rec team is going to try to replicate the atomic, which is the attack, right? So it looks like we had an issue there. So let me try another type of technique. Of course, this happened today. Let's see if I'm able to get away with it. I can also rebuild it, but it will take some time to rebuild. And this is also, by the way, it is a, it looks like it's having issues. So this may happen. When this happens, what I would suggest you to do is to rebuild it. I probably don't want to do that right now. So what I'm going to do is I'm going to show you let's see if I can show you the cloud one. And then we can take a look at, see if it will show me what happened yesterday when I was testing it before today. But going back to this, if we go into search and reporting, and we go into index equals, should be data here, attack. Let's see. These are the attacks that I actually executed before. And these are the attacks. This tells you what was executed, right? And against what. So here, the interesting thing is I was trying to re-execute this technique, which is T10032. So let's see, what is this? So if we go MITRE attack, we should be able to find that this technique is OS credential dumping, security account manager, right? So this is basically what Caldera is. So going back, it is registered as it occurred in the actual host. So I apologize. This always happens. where things I prepare them and then they break. But let's see. This is another of the things that you can use. Um, and again, you can use, for example, ESCU, which is part of the content updates that we do. Let's see if we can do credential dumping. Or we can do T0. This thing's playing games with me today. I apologize. But if this was working as it should, we should be able to find, right, the accounts that correspond to the techniques that we're trying to detect. Now, if this was me on my day work, I will destroy this, but I don't want to destroy it and rebuild it because we will go through the time and we're already at, we have, I believe, around half an hour left. So I want to try to show you as much as I can. And in this section, you can actually see the actual searches that may apply to what we're looking for, right? So going back, we were able to find the, sorry. In theory, this should have shown me, for example, today, one attack, but it's giving me an issue. And you can go into the ES content updates. And basically what I wanted to show you, which I'm not able to show you at this point, is search for the actual technique. Okay, let's see if we can use this. Search for the actual technique, execute the search, and you actually can see that is basically detected. So let's see, T013. Let's see, we can run it and see if it works. It looks like this might be broken at this point. It needs to be rebuilt, but you can see here that you can basically run. We actually, when we were testing zero logon, we discovered that the Mimikatz, because one of the things that happened with zero logon is first there was a disclosure, and then, like always, the community starts grabbing onto whatever an exploit was, and then they start adapting it, which is something fascinating. And we were able to, it was adapted to Mimikatz pretty quick. And we were able to detect the Mimikatz run with this. And again, I apologize again because this, of course, should have worked. But unfortunately, I wonder if I stop it and restart it again. Let me try that. Action, stop, and maybe we'll bring it back. Because I can do destroy, for example, and rebuild, but I don't want to do that. So I'm going to do stop. And if I do that, you will see how the machines basically, they go, they're basically stopped. And then what I'm going to do is I'm going to resume it back, try to execute again. Again, if this is just what will be happening to you or to me, and it had obviously time, I will simply destroy it and rebuild it. And if this happens, for example, so one of the things that may happen to you, and this is good that I guess it's a silver lining that this is happening, is that if this happens to you, for example, with the cloud version, you can always destroy it and redo it. So what happens sometimes is there are either hiccups with DNS or there are hiccups with downloads. And then, for example, Sysmon would not be installed, or the universal forwarder would not be installed because there was a hiccup and a timeout during the Terraform execution. And I suspect that has to do with this. And basically that costs the fact that your universal forwarder is not working, for example. So it looks like it's bringing back the Kali machine. There's my Kali machine. And again, most of you know the Kali is, but now we can use it. And then this is usually what happens when you hit stop and you try to bring it back. And this gets me an error. I'm just gonna go into the cloud one. Let's see where we are. So this is my Kali. So let's go ahead and you see my IP address. We can use this command to find out if they're on or not. And it should respond quick. And there it is. It looks like they're all on. We'll see about that. So if I ping let's ping the Splunk server 10.0. Yeah, communication. So we have now all our machines. Let's actually look at this. Oh, wait, found it. See that? This is the access LSAS memory dump for creation rule, aka technique 10 T1003.001. Here it is. Found it. And at least this went well. It took some time. Maybe I just needed to restart it. But I did execute that technique. I did not execute this one. Let's see if we can try another one. Let's try this one. Yeah. Let's see if we can get some here. And then, of course, the SEU is bang. There we go. So now, guys, we have done full circle. We have set up the infrastructure, replicated the attack, done the detection. Detection right here. Where is this coming from? If I click here, it will open and it will find it in Splunk. That's basically what it will do. But here's the detection, and the detection is part of our content. This is remember when I told you about how we produce detections and then we push it into content. What you see right now, this is the end result of what we do. Like we start with SPL, which is, you can see this SPL code. That SPL code goes into usually it's a YAML file, and this YAML has a structure. This runs through the attack range, detected, then it goes checked into the parameters, the parameters checked, then eventually this is compacted, packed, and published as an app, which is called the ESE. So I'm glad at least this worked. It was a good idea to do what I did. So now I know that I may try to do that. Let's see if this one is working. Yeah, it's giving me an error. I was told this was fixed, but it looks like it's not. Let's see. But when everything is working fine, you should see there will be like a nice analytics here of all the tactics you have executed and everything that happened, right? So I apologize for having issues with this, but let's move on to Caldera. Now, you can see, again, I'm gonna repeat it for clarity. We start here, and I know I was having issues here, but again, we'll go here, help, and then so you can see what the command is, and then we do -A for action. So we want to simulate a technique. We want to use a simulation technique. We were using 10.03.001. And then we need a target. And the target is the machine that we're doing this against. So we go here and see if this time will be reachable, and we'll go through. Let's see. So again, this is calling atomic red team executing the technique. And if we're lucky, and the stop, no, we're not. So if this was working fine, you will see this is successful execution. I'm glad I was able to show you how the detection occurred, and I'm glad I did this yesterday to have some data here in case this happened. So if we go here, what you see here is Caldera. So Caldera is a looks like I'm gonna have to, let's see, forgot my Caldera password. Tag range, conf. That's not. Let's see if we can find that Splunk was this. Let's see what Caldera is. Caldera, yeah, this should be the password. Let's try again. So Caldera runs on the same server that Splunk runs on port 8888. So let's go here. Jesus, admin, password. I wonder what's going on. I wonder if it's, let's type it like this. Then. See if this will work. Okay, here we go. We're in. So now what you see here is basically the interface of Caldera, which is we did atomic red team. We executed attacks via atomic red team, and now we're looking at the Caldera interface, which is our second attack simulation framework. So here we have the first thing we can check is agents. As you can see, there's an agent running our Windows host right here, so TCP, right? And it tells us that the privilege of what is running is user, and the PID is 2088. We can go back to campaigns, and we can take a look at adversaries. And adversaries are, usually there are existing profiles that we can take advantage from. So for example, if we select a collection, right, and you look at the icons, I hope you guys can see this well. The icons refer to the operating systems that this abilities, that's how they call it, this abilities, see here at ability, they call it ability, are applicable to. So in this case, for example, creating a staging directory applies to Windows, Ubuntu, and Mac. So let's see if we can do, for example, discovery. We were looking at collection, let's go discovery, and then discovery, we can do things such as identified active user, find local user, find user processes, view admin shares. So let's see if we can apply this actually. So I'm gonna go ahead and save this discovery. And what I'm gonna do now is I'm gonna go to campaign, and I go to operations. It is important before I go through this, since this is usually when the demo gods play with you. If you don't have agents on, and agents should be on and created as we install this, you shouldn't have to. You can, if you want, you can, there is actual way to deploy an agent. There are several agents. Usually man X is the the TCP one that we decided to use, so you can use Ragdoll. But if you do this, for example, you'll see the code. So basically, I will have to go on my Windows machine and most likely open a PowerShell terminal and run this, and most likely you will get a new agent. We decided to change to ManX because we were having issues with the agents in AWS. I suspected that AWS had some sort of a DPI technology that was killing some of the agents. So our agent is running. We have saved a profile. So now let's go into operations. So in operations, I'm going to name it test. And then here, I'm going to select, we can use all groups. I'm going to select discovery. I'm going to keep open forever, run immediately. See what else we got. Force atomic ordering. And then let's start. See what happens. So remember that I showed you the profile discovery. Remember that I showed you what items of the profile, the discovery profile, apply to the Windows operating system. Because at the end of the day, guys, we're running all this against my Windows machine, which is the Windows server. So once we applying this, watch, there is a percentage of the operation that's occurring. There is obviously, they use colors to show you the status of what's happening. And you can see, for example, that identify active user was successful. And then as the operations continue, you will see the actual progress on this. See, now we have identify local users, active users. It looks like it wasn't able to find user processes. Remember what I told you? They go by techniques and they want to see what techniques are successful or not. If we were trying to gauge what your organization would be like if these attacks are performed, the best way to be more accurate about this will be doing this against a golden image. So remember that. Remember that, because here's where we score. Here is where we execute, and we'll see, okay, how will we do? So were we expecting this agent to identify active users? Were we expecting this agent to fail to view admin shares? Now you know that with a user privilege, most likely we won't be able to do it. Or even is testing, for example, find the main controller. And I'll show you in just a minute. Let's see where we are. This is only 20%. This is going to take some time. And it takes some time to run, right? So remember, you can always expand this. You can deploy more machines and you can deploy more agents. And there are other good things that I may show you in just a second. Because I want, before we go, I want to show you what we're doing with the cloud only one. If you were to do the standard one, like if you went right now and clone the one that is in AWS, it will be exactly what you're seeing here, but in AWS. So it won't be VirtualBox, but you will have to either SSH or RDP in your actual host. So as you can see, I think, did we finish? No, we're still at 28. So it was able to discover, for example, permission groups were able to be discovered. We're not able to discover antiviruses, antivirus programs. So I think you get the idea at this point. This is actually a very nice way of visually seeing what the process of testing all these adversarial techniques against a host. And hopefully, if you do this from the perspective of doing a purple team exercise, for example, or a blue team exercise, so you can see clearly what's going on. So that's the nice thing about Caldera. And Caldera, of course, is open source and it's free. So you don't lose anything trying it. So we give you the entire package here. The only thing you're gonna have to do is obviously, if you want to test it against some of your stuff, then you're gonna have to deploy. You're gonna have to fix the configuration, obviously, so the network of the range matches your network, and you're gonna have to deploy these agents in host or even bare metal devices that represent your organization. So I think at this point we're at 32%. So I think you got a good grasp of what this does. There are other stuff that we can look at here. There are plugins, there are things that they call game board, or like if we go to Manax, for example, it's a coordinated access Trojan. And there are other things that you can basically play with, select the specific techniques or procedures. So I wanted to show you this. So now you have an idea what to do. And we have successfully, at least that we were able, at least in this case, we were able, it looks like the Caldera agent is definitely running, because obviously we wouldn't be seeing this. We had some hiccups with the ATR, with the Atomic Red team, and but thankfully I was able to run those simulations yesterday, and we were able to find the detections, and we were able to find the data at the Splunk. So as you can see, I hope I'm not overwhelming you with information, but this thing is fascinating. You can do everything you want with this. It's you can download it, install it right now. And then let's see what we got. This is, let's see if I can show you the, no, we're not there. This is attack range cloud. So action resume. Let's see if we, hopefully this is my third demo. This will go better. So right now what I'm doing, guys, is basically restarting the cloud only attack range. This is like in beta. This is not yet production quality ready, but I'd like to show you what we are trying to do. So if I do that, which is the command, you can see that there is a cloud attack range right here. Let's check it out. There we go. Why? It took a little bit the last time it restarted. There we go. And I think I changed the password here. And there's my Splunk. This is my Splunk instance that was created during the creation of the attack range cloud only in the cloud. So in here, we should be able to see search history. AWS, let's do this. So if I add AWS, check that out. Those are logs for CloudTrails. Right there is CloudTrails. And let's see if the demo logs will help me on this, and we can execute an attack using Leonidas. So Leonidas, which is something like kind of brand new, Leonidas is a attack simulation framework created by F5, F-Secure Labs. We looked at it and we thought, hey, this is a great idea. Maybe we can adapt it to ours. So we're taking a look at it. What I did here, just so you know, is I cloned Leonidas inside my environment, and as you can see, if you look at in my environment, I also have a Kubernetes cluster. And this Kubernetes cluster, if I am not mistaken, is a WordPress. Let's see what we got. If I'm not mistaken, is a WordPress. Not sure how long it would take. Oh, wait a minute. No, wait a minute. This is not the right. No, it's not right. Sorry. I don't think this has. Oh, yeah. I was wondering. Like that looked like a pip address. Let's try this better. See here. There might be some issue with the external IP address here, but this, in theory, should be the IP address of my attack range WordPress cluster. Like I said, guys, this is in beta. This is not really in production yet. Let's see if we can execute an attack. So basically, let me show you a little bit. What we're trying to do here basically is we create a Splunk instance, like I just showed you. We get CloudTrails logs, and then we replicate attacks, and then we grab the data, right? So if we go into Leonidas, right, and we go into definitions, you can see that this is also following the MITRE attack, which I find this very useful, and we hope to collaborate. This is a great project. I like this. So you can see all the faces, right? And this is basically matches MITRE attack. But remember, the cloud for a lot of times, people thought that the cloud was just an extension of the perimeter. That's not true. Every time you deal with either GCP, Azure, or AWS, is a completely different deal. So I'm running out of time, so I'm gonna go ahead and let's see if we can replicate an attack in the cloud. So here's one. So in this case, I'm going to simulate a file, right, that is inside Leonidas. And it's going to try to enumerate AIM users. So let's see if it works. So that did not work. See if we can try another attack. Let's see if we can add a user. So it asks you, do you want to execute this attack, yes or no? We already executed this attack yesterday, so not sure if it's going to tell me no because the example user exists already, but you say yes, and then it gets me an error. So that's something that we got to fix if we want to re-execute. So the answer is the entity exists already, and actually I'll show you. Look for it, we're going to find it, either by listing keys or by creation of the user, right? Notice that it locks the Voto user agent, which is usually corresponds to the use of AWS CLI. So, and with that, I pretty much show you the entire picture. I kind of skip a lot of the slides and just went into hands-on. Let's see if this is how it should have looked like when we were looking at the dashboard. And again, I'm positive if I rebuild it, it will work. But this is how it would look like, and this is basically what you would look at the bottom. What were the simulations that you executed, the atomic test, the host name that you executed against, and then we already saw Caldera, and of course the Kali. You can always use Kali, and in this case, it just use a multi-handler, interpreter, and then found it. It's just an example that you can actually exploit your machines, not only in the cloud, but locally as well. And hopefully we will have this for as we advance and we develop more in the cloud, we'll have endpoint cloud, endpoint local, cloud only. And that's what we're looking at right now. We're even getting more ambitious. We want to create a complete data repository of all these attacks and help you replicate the attack with the data so you can create the detection as well. So there's a lot that we want to cover, and it's going to take some time. But again, I invite you to use this project. I invite you to test it. I invite you to suggest fixes and do a PR. And with that, I think this is it for me.
All right. Thanks, Rod.
Thank you very much.
All right. So we'll jump on to the question and answer portion. Let me just check on the question and answer deck. I don't see any questions here.
You can always reach me out via Twitter.
Now, but I'm highly encouraging our attendees to please.
Sorry, I think Sir Jamie is having
He had a
some
technical issue.
internet. Yeah, it kind of sucks here.
No, I'm right here. I thought Rod was going to say something.
Okay.
That's perfect. All right. Though, yeah, there are no questions. Jay, could you see if there are any questions on your end? Because on my end, I couldn't find any questions on the Q&A box.
I can only see a chat. Can we have the copy of the slide for our reference? We will be actually giving up the slides soon. We'll be posting it on the website, so no need to worry about it.
Okay, cool. I hope you have a lot of fun. And listen, you can reach out to me via Twitter. Or you can, there's a contact for the Splunk security research team. Patrick or Jose will be glad to help you, or I will be glad to help you as well.
We will definitely follow you on Twitter, and this is really a good topic because a lot of people have don't know what red teaming and how to automate their exercise with adversarial simulations.
Cool. I hope I was able to provide a little bit of a light on this.
Yeah, because here in the Philippines, there's a mixture of comparing VAPT to red teaming. So there's been misconceptions that they are the same, and thank you for giving some good points that they are really different.
Oh, I'm glad. Thank you for having me, guys. Good luck, and we'll be in touch.
Yeah, thank you.
Wait,
thank you for your time too, because it was very, very detailed.
Yep. So there's another. Someone raised their hand, so I think there's one question. One of the attendees raised their hand. Let me check. Sorry to cut you shortly. I think there's none.
Yeah, they just wanted to say it's very detailed. It was an awesome talk. They really appreciate that you've got through all those details.
Of course, that was the point. That was to get your money's worth. Thank you.
That's nice. That's nice of you, Rod. All right. For our attendees, again, Rod, thank you. Now I'll be addressing our attendees. For our attendees, we'll be resuming this 1 p.m. Manila time. We trust that you all are might be peckish already, rooting for a bit of lunch. So we'll let you have a break, and then we'll get back by 1 p.m. So I'll see you later.
Another announcement, Red Team Village CTF is still ongoing. So make sure to register if you want to play the CTF.